hello Hayden. We were just saying, so if you look at Teams, the class notebook, whatever, if you go into, I think it's the vectors one, got Friday on my mind. If you go to lessons, we've got revision guide questions and you've got solutions. You're probably going to do these after you've done a fair bit of the review questions. And oops, one of the things that we talked about was that we didn't really do a lot from chapter 5 with the vector geometry, because I think we sort of did some of it with complex numbers, but it's nice to go back over. So let's have a look. Nice and simple. This was question 97. I think there was one before as well, maybe 96 or something before. That's a little bit more complicated. This is cute. So you're having a read. Yes, we've got a trapezium. We read. What's one of the things that you should do as you're reading straight away? Yeah, so I've got here AB is KQ. So straight away, I'm just going to say that's KQ. They've already put the P and the Q there. Why didn't they do the other? Well, they're checking that you would label it yourself. All right? Show that BC is this. So we're going to start. And you've got to now be really careful about what you're putting down on paper. Okay? So if I want BC, so B to C, how do we actually get that? Yes, Mac. Vector addition. So you're actually going to go B to A plus A to O and then O to C. So we have to write that down. Just in case you make a mushtaq, but you're writing B to A, yeah, plus A to O. You're resisting just going straight into minus KQ plus, I got AO, OC. Oh, that was a good show. OC. Now, for me, I sort of then have to erase that, because otherwise I would think that KQ was going the other way. Yeah? So here we go. We have AB is KQ, so BA must be the negative thereof. Remember that? Are we remembering this? A little bit? Not too bad. Now, OA is P, so AO, negative P. OC, that is still just Q. A reminder, when you've got show that questions, it's really tempting to just now go, oh yeah, it's what we got. Irritate yourself and put in that little bit of an extra question there. So actually go Q, take KQ, I don't know, so you can, just so they know you're not just messing around. 1 take K, take P, and that's what we've got. Agreed? M and N are midpoints of OA and BC respectively. Show that MN is parallel. MN is parallel to OC and is K plus 1 over 2 times its length. Now, lovely beings, before you even start, should you state what's in your head? How are you showing that that is going to be parallel? No, you don't know that. You're trying to prove that. But I'm just saying, how do you prove that two vectors are parallel? Yep. Have to have the same direction. Sorry, that's what they said. So how do you notice it? Wouldn't we say that two vectors are parallel if now, what are they? I'll use little a. If little a equals K times B. So basically you're going to find MN and you're going to hope that is K plus 1 times its length, right? K plus 1 over 2 times whatever. Does that make sense? But again, put down possibly you're thinking, if it's, you don't write an essay or anything. But anyway, away we go. So how are we going to get MN? Like Mac said. Who would like to play? Liz? You missed that. I said Liz? Hayden, you're missing it, but we have a special guest in the classroom. The Queen has come to visit us, as in Elizabeth II, holding a ruler and everything. We'll show you pictures. All right. So, Ethan, I think that's where we put another mark on the board for you, Ethan. So, Ethan said 1/2 OA, and we go, no. What did we just say? Try not to go straight into the... Oh, sorry, is that what you said?
Well, I said 1/2 OA, but that is OA.
Oh, yeah, okay, I'm going to go. So, MN would be MO. Yeah, but... Oh, okay. You could go up. You could go down. Oh, okay. Go up. Okay.
By doing that, you're actually doing
BC, yeah. I mean, it still works, but that's all right. Fair enough. I stand corrected. So, MA, my initials backwards. MA plus AB plus BC. Agreed? BN. Good. Didn't agree with me. Sorry, Hayden. And you got your little double check. Same letters. Last ones give you what you want. So, common thing that happens in a test. I've made a mistake. Who can find it? Brackets. Okay, so you're going along 1/2 BC. We've just got the BC from up there. You're going 1/2, and then if you're not careful, you haven't put your brackets around, then you're going to make a mushtak. So always just double check. Okay. When you solve that, hopefully you'll be able. I've made another mistake. Oh, I did. Look at that. Look at that. Who's dyslexic? On fire today. On fire. And in front of the Queen and everything. So embarrassed. What you should be looking at too, got your outline happening. Okay. Oh, look at that. Subtopic 4.1. What is a vector? Well, hell's bells. How can I test that? Right. Can you write a vector? Can you pop it in Cartesian form, parametric form, vector form? Right. This is your outline. This is what I'm looking at as well. Whether or not paths of two particles cross. Scalar product, dot product, cross product. Area of parallelogram. So all of these things can be assessed. Distance, point, plane. So the geometry bit, was that this? Where'd it go? Prove geometric results in the plane and construct simple proofs in 3 dimensions. Yeah. I mean, yeah, that's all right. Parallelism, perpendicular, and properties of intersections. So that's making sure we can interpret. I've got something for you, Ethan, and for the rest of the class. Keep watching this space. Hello, Hayden. They decided to store everything in Teams. So if you go into Teams, class materials, vectors, you've got like just the basic files. I'll stick it everywhere as well, but that's your go-to for basic files because it's easier for you guys to see it all, correct? Right. So linear equations, if you have a look at that, I'm going to have to tap it again. Why not? It hasn't got the, I'll tell you, that's got 7. Which one's missing? Thank you. Unique solution when they all, so I don't think we need that one, but it's just showing you, sorry, I don't know if it's not coming up very nicely here. Right, so why do we know that these are parallel? Do we really need 1, -2, 3? This is the same vector, it's just, yep, times by -1. If this was, instead of 8, if this was -5, what would you then say? Files, class materials. They wouldn't be parallel if that was -5. Come on, peeps. Yep, one on top of the other, coincident, coplanar, right? And then this one, again, you've multiplied by 2, but because that is not 10, then they're not coincident, they're not one on top of the other, that's why it's parallel. Gotcha? If you look at over here, if we're looking at this one, you can see that the top line and the bottom line. So that would be their two are coincident because it's the same plane. Sweet? So that was a cute little visual, shows you some of that, but I don't think you need to copy that on your help sheet or anything. It's just there for you to remind you, but if you want to, by all means. Hayden, if you're listening to this, you could claim your prize when you come back. All right, now, first off, Bobby and Bella did a really good question. What was that one? Review set 6A, question 10. Quite good, and I think you could take some of that and apply it, if you wanted to your mosquitoes, your investigation. So it's about, is it submarines or torpedoes or something? Torpedoes, that one starts 2 seconds after the other one. Minutes. So you could think about that with your mosquitoes and when they do. Anyway, for a prize. And Hayden, if you promise me that you got these, then you could claim your prize. So let's look at question 87. We're just going to do some randoms. Bobby and I just chose some randoms together. Show that the vectors P and Q are perpendicular. No. So you don't have to do. You're just going to tell me how. So how would you show me that those two vectors are perpendicular? Finn. Does he get the thing for just saying dot product? No. So you have to say, prove that the dot product would equal 0. And if you were writing this down, you would say perpendicular if P dotted with Q equals 0. So you're actually showing, remember back to year 11, when does something have one solution, two solution, no solutions? You should actually say discriminant is less than 0 or greater than, and people didn't, lost marks. So sorry, no prizes for that round. Find two vectors R which have length 3 and are perpendicular to both P and Q. So wait for my question. Which have length 3 and are perpendicular to both P and Q. So question, how do you find a vector that is perpendicular to both P and Q? Bobby, you were quick, but he was slow about putting, yes?
Cross product.
And to make sure you claim this cross product, how do you find the cross product? For that one, what would you do?
So the two squiggly.
Oh, no. So for this one, I would go straight to calculator because I've got all the values, 2, 1, -2, 2, -2, and 1. I'd go straight to my calculator, save myself heartache. If it said algebraically, well, then I'd do that determinant I, J, K, blah by hand, or if there was some more variables. Okay?
It doesn't matter.
No, everyone will get one, don't worry. Prize number 2. If we have a vector, how do I make sure that it has a length of 3? Yes. And how do you find the unit vector? So sorry, that was find the unit vector and multiply by 3. And how do you find the unit vector?
divided by the modulus of its.
So find its length and divide through. You do get a prize, but you only get it if everybody can answer a question. Okay, read 9A. 90A. So a lot of words there, but basically we've got vectors P and Q. We work out the cross product of P and Q. Why would the dot product of P times your cross product equal 0? And, Eden, why would Q dot product with P times cross Q also equal 0? Why should we expect that? Eden? A. We've got vectors P and Q. They've asked you to find the cross product of P and Q. Why is it sensible, why is it expected that if you then go P dotted with the cross product of P and Q, it should equal 0? You could use phone a friend. They're phoning a friend.
Because P times Q is
Cross.
P crossed with Q is perpendicular to both P and Q, so therefore P or Q dotted with that will be 0 because they are
Niall is nodding his
perpendicular.
head. Nodding his head. Yeah. Correct. Right, so we've got to get that through. Some of us are still not realizing P cross Q, that is the vector that is going to be perpendicular to P and Q. And then, obviously, dot product equals 0 when they're perpendicular. Happy days? Maybe. Could we go yes, tick for part 1? Could everybody be able to do C part 1? We've got 3 points. How would you find the equation of A, B, C, Kelly? Wait.
You'd create 2 vectors using the points on the actual thing, and then use the 2 vectors to using cross product to get the normal vector, and then use the normal vector to
Yeah. So sub it in. So AX plus BY plus CZ equals D by subbing in your points. But yeah. So we should be able to do. Sometimes it's harder to explain in words than actually do it. Okay, an equation of the normal to the plane through the point B. Could you find that? Why? How? Sub into what? Find the equation of the normal to the plane. So what is that? Yeah, it's the direction vector. Well, not direction vector, but what do we need to find the equation of a line? You need the direction vector for a line, but it will equal the normal vector of the plane. Plane, direction vector of the line. Correct? I love that Eden's not listening to any of this. Area of triangle ABC, could we do that? Yep, because we know our formula. Yep. Okay, part A, which are lines and which are planes? 91. First one, line or plane? The plane, the plane. Plane, a bit sneaky with that one, right? But if you expand, it's not like that. Cartesian form. Vector form. Need to know, make sure you know those forms. We went through the outline there. Find the point of intersection of each plane with the y-axis. How do you find out where something hits your y-axis? Each plane. So Kanal is saying lots of words there, but yeah, you can look that up. Show that one line is normal to one of the planes. So again, Eden, we need you to look at this one. Show that a line is normal to a plane. So that would mean the normal of the plane is the direction vector of that line. Does that make sense? What happens if you wanted a line that was parallel to the plane? Yeah, so dv by n would then equal 0 if they're parallel. Anyway, making sense? So is one line normal to one of the planes? Bit hard to tell. What have we got? 1, 4, 3, 1, 2, 0, 1, 2. That's no good. I'm sure you'd be able to work that out. But basically that's a thing of, can you get the direction vector of the lines regardless of what form they're in? There's my direction vector there. I.
So that
Bottom 2. 2 minus 3 minus 2. There you go. Right? So coefficients of your x, y, z for your plane. Show that the two lines and the two planes all have a point in common. It's got to be something simple with that. Maybe look it up. But go through, have a look and see, can you get started? So sometimes your time is precious. You do have work solutions for these and even your reviews. So if it is, I'm just going to save myself a bit of time to know how I'm going to get started, that would be great. But then obviously actually do as many questions as you can. Capiche? Okay.